The standby power system supplies AC and DC power to important electrical components when normal AC power is not available from the engine or APU generators. The standby power system uses the batteries and a static inverter to supply power to these buses. With no other power source available, the batteries can supply power for a minimum of 60 minutes. Battery power is the emergency source of power for the DC standby bus, the battery bus, and the static inverter. The static inverter changes 24-volt DC battery power to 115-volt AC power for the AC standby bus. There are two controls related to the standby power system. Let's look at the standby power switch first. The standby power switch has 3 positions and is normally in the auto position with the guard closed. In auto, the standby buses and the battery bus are supplied power from their normal power sources. But if all sources of AC power are removed, the standby power control unit automatically changes the standby system to battery power. The power change can occur on the ground or in the air. Now move the standby power switch to the off position. In the off position, the AC and DC standby buses and the battery bus are disconnected from all power sources, normal or battery. The standby power off light illuminates when power is removed from one or more of these buses. Move the standby power switch to the battery position. Battery power is now manually connected to the standby power system. Move the standby power switch back to auto. The battery switch is the other standby power control. The on position always energizes the switched hot battery bus and the other circuits to automatically change to battery power if normal power is not available. Move the battery switch to off. All power is now removed from the standby power system and the switched hot battery bus. The standby buses operate these important components. Touch each menu item for more information.